Hey, Billy! Billy! Is this on? Hello? Okay, guys. Weird. This is lesson 17, I believe. I think I might be using this old camera I found to make these videos because it's taking too long to upload to YouTube, but hey, we'll see. I'll do a test run first. You guys tell me in the comments and stuff if it was better or worse. Not this video, the next video. Better, worse, whatever. So let's start talking about this. We are going to be understanding the definitions of sine, cosine, and tangent ratios, and we're going to use trig ratios to find unknown side lengths and right triangles. Same as last time, just a little different today. Use these links. These are great. I would never, ever, ever do this. Finding sine, cosine, and tangent with a scientific calculator on iPhone. And not just because I can't stand iPhone, even if it was Android. That's a hard no. If you must use your phones and you have Android, you can download this app called Wabbit. If you click Wabbit, you can download a TI-84 Plus Silver. That's what we have at the school. And this operates the same way as you would normally see a graphing calculator like this one. But it's on your phone. See? Second off. It's on your phone. Those are my two daughters. If you can't afford one of these, don't worry. I'm in the same club. I have had this longer than you guys have been alive. There is also graphing calculators on the internet. You can go to Desmos, www.desmos, www.desmos.com. You can go to Desmos. They have a great graphing calculator on there. You can use other ones from like, what are those cheating websites? Photomath, I think, has one. Khan Academy might have one now too, but I trust Desmos. It's up to you. Use your calculator to find the following values. Round to the nearest thousandth. How many zeros in 1,000? There are 3 zeros, so that means thousandth is the third decimal place in. To do the third, remember, you go from the fourth. 5 or more, let it soar. 4 or less, let it rest. Student told me that back when I was teaching middle school. I'm going to do the first one because I'm not doing all of these. It's not pointless. It's just super, 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 dare I say, easy. Sine 25. Close parentheses, enter. There you go. 0.423. 3, because the next one is 6. 0.423. 0.423. What that means is that every single opposite over hypotenuse with one angle being 25 degrees will have a ratio of the opposite over hypotenuse being 0.423. Doesn't matter what size it is, the measurements, the ratio will always be 0.423. Solve for y. Looking for adjacent or opposite, depending on which reference angle you start. If you're starting here, it's adjacent. If you start here, it's opposite. Oh, look, they're making us do it both ways. Go through this. It could help, but let's move on to the next question so that I thought there was one of those for us to do. Oh, I guess there's not one for us to do. Let's say that this wasn't 18. Let's say that this was 15. Now that changes all these numbers, so I'm just ignoring it altogether. How do we set it up? Using sine to solve for y, we're getting the hypotenuse. To get the hypotenuse, using sine. Well, this is the opposite of what? This is the opposite of m, right? So we would say sine of 62 is equal to opposite over hypotenuse, 15 over y. Now, how do we do this? If you multiply by y, then divide by sine 62, you'll get the answer. Faster way to do it, if you just move the 15 divided by. 15 divided by sine 62 is equal to y. 15 divided by sine 62. 16.9, so on and so forth. That's it. Cosine. How do we use a cosine? Well, this is adjacent to 28. So we do cosine of 28 is adjacent over hypotenuse, 15 over y. Again, you can just move the 15 over here. All you do is you multiply by y and then divide by cosine 28. Let me show you what that looks like. Let me show you why this trick works. If I multiply both sides by y, let me do it in a different color so you can see what I'm doing. These are parentheses, sorry. So I have y cosine 28 is equal to 15. And then I'm going to divide by cosine 28 to isolate y. And there you have it. The shortcut just says you can do this in one step rather than three. So I now have y equals 15 over cosine 28. This shortcut where I said you can just move the 15 over. See how that works? 15 over. Now, if you knew the bottom and didn't know the top, all you do is you multiply by the bottom and you would stop here. But if I were to do 15 divided by cosine 28, it will be this exact same number, 16.988555076. 16.988555076. See? Same exact number. Yay, it worked. Next, what is the value of BC in the diagram below? BC. Here's one of the things. I use that symbol all the time. This says basically 4 equals 3.99999. Is this an equality? No, but this means about equal to. 4 is about equal to 3.9999. Right? That's what she's talking about. What is the value of BC in the diagram below? When could you use this? Oh, I don't know. Anytime you want to measure across a lake, how can you possibly measure across a lake? You can't. But you can measure across the shore. I suppose you can now using laser measurements and all that, if the laser will go that far, but hey, who knows? How do we do this? So which trig ratio relates angle A, side AC, and side BC? AC, BC. AC, BC in relation to this. So this is adjacent and opposite. Tangent. Copy and paste one of the options below and use it to relate angle A, side AC, and side BC. So sine of 24, opposite over hypotenuse. Do we know that? Do we know anything about AB? No, we don't need to. Can we use cosine, adjacent over hypotenuse? No, we're going to use tangent of 24. I believe this is what it's asking for. So tangent of 24 is equal to opposite, we don't know, BC over adjacent of 350. How do you solve when it's divided by 350? What do you do when you're solving an equation where you have x divided by 4? How do you undo divided by 4? Do that here. Okay? And then you're going to get BC. And literally it's not even kidding. I'm not even kidding when I tell you that's how they measure across a lake. They don't take a string and a little rowboat and paddle across and then measure how long the string. No. 1, the string would break under its own weight. 2, the water would take it and break. 3, the wind would flex it. 4, no. Just no. Now this. Complete the exercise. Solve for a side in a right triangle. Do you know how big a ladder is when you buy it? Considering how when you buy a ladder, you buy it by the foot, I think you know how big it is. Are you able to measure the side of your house from bottom to top? I'm not. I don't know anybody who is, even with a laser measurer. So what do? Well, you can download an app for that, which sucks, by the way. I tried it. It is not accurate in any way, shape, or form. So what do? Math. Trig. I just wanted to point out that my neighbors yesterday, or the day before yesterday, were cutting down trees in their backyard. And guess what math the tree cutters were using? I'm not even kidding. I went up and I talked to the guys, and they were actually doing trig problems beforehand in order to get this done. Where is it? No, I took a picture. Oh, here we go. I don't know if you can see this, but this dude was standing an exact distance away from this cherry picker as he was cutting this tree top up here. They had already calculated exactly how far he needed to stay for when the top of this tree fell down so it didn't crush him. Brilliant. Math is life and safety. Moving on. Love it. There's so many different things you use trig for. That's just one of them. Which trig ratio relates to the angle of the two known sides? We know that. Excuse me. Can you measure this? You could. Can you measure this? We already know that. Can we measure this? We don't know. We could. So we know this, and we know hypotenuse. Which two use hypotenuse? SOHCAHTOA, 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 SOHCAHTOA. Copy and paste one of the options below, and so you got to figure it out which two and use it here, same as the last one, and solve. If you have further questions, you know how to get a hold of me. This was a very short one. See you guys.